Hello, 6th grade scholars. So tonight's video is about the difference between rational and irrational numbers. And you probably remember last week I used the word rational numbers when talking about what our test would be over. So I said we were going to add, subtract, multiply, and divide rational numbers, which included integers, fractions, and decimals that ended or repeated. So what that really means there is that rational numbers are any number, and I need you to write this down in your notes. Rational numbers are any number that can be written as a fraction. Because if you look at the first 5 letters of the word rational, it spells out ratio. So any number that can be written as a ratio is a rational number. Integers can be written as the integer over 1. Fractions obviously are already in fraction form, and any number that's a decimal that ends or repeats can be written as a fraction. So remember how we've been learning about 0.1 repeating is actually 1/9, stuff like that. So rational numbers, I'll say it again so you can write it down, are any number that can be written as a fraction. Okay, now you're about to watch a video from a guest that thoroughly explains the categories, but I will have notes after that video so that you can specifically write some things down, okay? So hang in there with me. I think it's kind of fun, so hopefully you do too. Okay, bye.
Rational numbers versus irrational numbers. Let's do this. A decimal that terminates is rational. There's a definite end to it. Repeating decimals are rational, even though they don't stop. And plain old integers, also rational. Now let's look at what's not. Irrational numbers are tricky little fellows. They think they're clever. Endless decimals that do not repeat. They just go on forever. Now check these examples. Tell me if they're rational or irrational. 4 1/10, that's rational. -10, that's rational. 23 4500ths, that's rational too. How about 0.3333333? Yeah, that's rational too. Pi is an endless decimal, so that's irrational. The square root of 2 is endless as well, so that's irrational. Rational numbers versus irrational numbers. Let's do this. A decimal that terminates is rational. There's a definite end to it. Repeating decimals are rational, even though they don't stop. And plain old integers, also rational. Now let's look at what's not. Irrational numbers are tricky little fellows. They think they're clever. Endless decimals that do not repeat. They just go on forever.
Okay, so just to summarize what that video was saying, rational numbers include just regular numbers, which we call integers if we're including negative numbers. So something to the effect of -1 or 7 or 23 or -100. All those are integers and they're considered rational numbers. Also, fractions is part of that list. 1/2, -1/2. Improper fractions are part of that, 23/7, or even mixed numbers, 7 1/4. All those are included in rational numbers, anything that's a fraction. Also decimals that terminate, so decimals that end, 4 1/10, 3 2500ths, etc. I think you get the idea. And then also decimals that repeat. So he showed on the video this with the ellipsis at the end, the ... But I also want you to be aware that sometimes repeating decimals get the lines over them. You've probably seen those before. 4.2 with the repeating line over it. That just means that number is repeated forever, and those are also included in rational numbers. So please make sure you get all 4 of those written down in your notebooks, as well as a couple examples, whatever is helpful to you. And then you can move on to the irrational numbers slide. Okay, so irrational numbers are a little bit easier to define. There's only one category of irrational numbers, and that's decimals that never end and never repeat. So he mentioned pi in the video. That is an irrational number, 3.14159, and then lots more after that. Those decimal numbers never repeat, and they just keep going forever and ever and ever. Sometimes they have contests to see how many digits of pi people can recite, which is super nerdy, but I think it's kind of fun. Other kinds of numbers that fall in this category, a lot of times square roots will be irrational because their decimals will never end and never repeat. For instance, the square root of 2, 1.414213556. You get the idea. It just keeps going and never repeats any of the numbers. Be kind of careful with square roots, though. Not all square roots are irrational. For instance, I'm sure you know this one. The square root of 4, that's 2, which means that is actually not irrational. It's a rational number. Even though it starts off as a square root, the actual value of it is an integer, so that would make it a rational number. Okay, so make sure you get some of this stuff written down in your notebooks as well about irrational numbers, and then you can move on to the IXL lesson. Thanks.